Chapter 5, Lesson 5, Dependent Events. Dependent probability is the probability of compound events that do affect each other. This means it changes the total number of outcomes or the denominator. Remember, independent events, they do not affect each other. I demonstrated yesterday that if I had 10 Jolly Ranchers, the probability of selecting a grape and putting it back does not change my probability of selecting a grape again. Those two probability fractions would remain the same. So yesterday you saw a lot of with replacement. Today we have without replacement, meaning when you take an item in a probability event, you keep it, and it changes the total number of outcomes or items that you currently have. We will be doing a couple examples with these solids, stripes, and white circles you see. The probability of a solid is 1 out of 6. You assume that that probability occurred. Therefore, we no longer have the solid circle in our outcomes. I will actually cover it so that we know that is no longer an outcome. Therefore, we multiply, because and in probability means you multiply, by the probability of getting a blank circle. Now we have 2 blanks out of a total 5. And we multiply these fractions like we normally would. You have 2 times 1 is 2. 6 times 5 is 30. These both can be simplified by 2, and you get 1 over 15. Let's reset and see if we can determine what the probability of getting a solid and a stripe. The probability of getting a solid is 1/6. I'm going to take that one out of my outcomes. Therefore, what is the probability of getting a stripe? You are correct. It is 3 out of 5. Multiply the two fractions together and we get 3 over 30. These can both be simplified by 3, and our probability is 1/10. Let's reset and try the third one. What is the probability of getting a solid and a solid? So the probability of getting a solid the first time is 1 out of 6. You assume that that event occurs. So when I take that one out, what would be the probability of getting another solid? It is 0 out of 6. Again, you assume the first event occurs successfully. And you are correct. The probability of getting a solid and a solid is 0. Are there any questions at this time? Let's look at number 1. There are 20 yellow, 6 green, 9 orange, and 5 red cards in a stack of cards turned face down. Once a card is selected, it is not replaced. The not replaced means it is a dependent event. Based on problem 1, find the following probabilities. So, actually it says, why is the problem above considered dependent probability? Do not repeat the definition. It is considered a dependent probability because keeping the card, or keeping the first card, changes the total number of outcomes. And because it changes the total outcomes, it is a dependent probability. The second probability is dependent on the results of the first probability. Number 2, based on problem 1, find the probabilities. So what I have done is I have drawn a few circles so we can kind of see how this plays out when we select the first probability. So on number 1, it says what's the probability of an orange, and then another orange card. So let's take a look. It says we have 9 orange out of how many total? Well, let's see. That's 5, 10, 15, 20, 25, 30, 35, 40. We have a total of 40 cards. So the probability of selecting an orange is 9 out of 40. So I'm going to write 9 out of 40 times, I'm going to cover up one of the orange ones. Now what is the probability of selecting an orange again? You are correct. It is 8 out of 39. Remember, once you take out the first one, you're reducing the total number of outcomes by 1. So the probability of getting an orange on the other one is 8 out of 39. Now I can simplify this. I see that these are pretty large numbers, so what I'm going to actually prefer to do is cross-simplify them before I multiply them together. 8 and 40 can both be simplified down to 1 and 5. 9 and 39 can both be simplified by 3. Therefore, this 9 becomes 3, and 39 becomes 13. So now we have 3 times 1 over 5 times 13. I know that 3 times 1 is 3, and 5 times 13 is 65. So the probability of selecting an orange and then another orange is 3 out of 65. Let's see if we can do that again with number 3. The probability of a green and then a red. So if we take a look at our circles or cards, what is the probability of selecting a green the first chance? You are correct. It is 6 out of 40. So the probability of a green is 6 out of 40. You assume that the first probability successfully occurs. So I'm going to go ahead and cover up that first green. Now it's asking us what the probability of a red card is. It is 5 out of 39. Because when we assume that we selected the green the first time and we held on to it. We did not replace it. So now there's only 39 cards in our stack. So it is 5 out of 39. And again, I see these are pretty large numbers, so I'm going to go ahead and cross-simplify. I know that 5 and 40 can both be simplified by 5. So this becomes 1 and 40 becomes 8. I know that both 6 and 39 can be simplified by 3. So 6 becomes 2 and 39 becomes 13. I now have 2 times 1 over 8 times 13. Well, I see I'll go ahead. 2 times 1 is 2, and 8 times 13 is 104. I recognize that both of these numbers are even numbers, so I'm going to go ahead and divide them both by 2. 2 divided by 2 is 1, and 104 divided by 2 is 52. Are there any questions at this time? I will give you 4 minutes to see if you can do number 4 and 5 on your own. Take a look. Did you get the same 9 over 260 and 5 over 78? If not, let's take a minute and see if we can figure out what we did wrong. Let's take a look at number 6 together. This one has complement events. The complement event is when it says not, which means we're looking for everything except for what it mentions. So number 6 has the probability of a card that is not yellow. Well, let's take a look. If I know that 20 of them are yellow, then I can see that the other 20 are not yellow. Therefore, the probability of not yellow is these 20 out of the total 40. So again, I'm going to assume that one of these is selected. So then I can look at another card that is not orange. So if these are not orange, there's 9 oranges. The problem is we only have 39 of them left. Remember that. Remember that our denominator goes down by 1 because we have selected a color other than yellow. So now I take a look and I want to know how many of them are not orange. Well, I can see that if there's 9 oranges out of 39 of them, yeah, there's 9 oranges out of 39, how many do I have left? Well, you might have to do a little bit of math on that one. If there's 39 of them, you are going to subtract the 9 oranges. Therefore, there should be 30. So that's 5, 10, 15, 20, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. I don't know, I think I counted wrong. 5, 10, 15, 20, 2, 4, 6, 8, 10. I did. I counted wrong. So if I cover these up, because we want the not oranges, I'm going to go ahead and cover those up because we're not getting these. So how many are not orange? You are correct. It is 30 out of 39. And then I can multiply these together. Again, I have some pretty big numbers, so I'm going to reduce these both by 10 and get 3 and 4. I'm going to go ahead and multiply these together. So I've got 20 times 3, 4 times 39. But I do see that 3 and 39 can be simplified. And so can 4 and 20. I'm going to go ahead and just multiply these together. So I have 60 over 156. I'm actually going to move my number over here because these can be simplified. I think they can both be simplified by 4. 60 divided by 4 is 15, and 156 divided by 4 is 39. These can both be simplified by 3. It is a lot of simplification, but you're not going to have to do this very often. 15 divided by 3 is 5, and 39 divided by 3 is 13. So, the probability of a card that is not yellow and another one that is not orange is 5 out of 13. Again, this is a long process, so just take it one step at a time. Let's reset and see if we can look at number 7. Number 7 says, a card that is neither red or orange. Okay, so neither red or orange. I'm going to take these off. Neither red or orange. Oh, I need another one. So neither red or orange means I have how many left? I've got 20, 2, 4, 6. So neither red or orange means it's 26 out of 40. So we assume that one of these is selected. So I'm going to select one. And the next one says neither red or green. So I'm going to keep those reds covered, and then I'm going to cover up the greens. Which means, how many do I have left now? Well, let's see. 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So now I have 28 over 39. And remember, your denominator needs to go down by 1 because you assume that the first event occurred and you do not put it back. So now I am going to start simplifying these and multiplying them. I do recognize that 40 and 28 can both be simplified by 2, so I'm going to do that first. That makes it 14 and 20. Oh, that goes down even more, so I can do that by 2 again, which gives me 7 and 10. So now I have 26 times 7 over 10 times 39, which is going to give me 182 over 390. And since these are both even numbers, I think they can be divided by 2. I know they both can be divided by 2. I'm going to divide them both by 2 first. You get 91 over 195. Wonder if these can be divided by 3. Doesn't look like it. They can't be divided by 3, but I tried 7, and I was able to get it down to 13 over. Well, that doesn't work either. So maybe 91 over 195 may be our answer. Like, nope, that's it. The 195 divided by 7 gives me another decimal, so that's not going to work. So 91 over 195, that's it. The last two, number 6 and 7, are a process, but it is okay Take your time, one step at a time. You might be able to go back and take a look and see what things that you can simplify if you find your numbers are getting too big. What I would like you to do is finish 8, 9, and 10 on your own. As soon as you are done, I will check them. When you have them correct, I will give you your homework for the evening. If you have any questions, please raise your hand.